Right. So I'm starting. Right. Thanks, Yusuf. So I'm gonna go ahead and start the recording now. All right. So where we finished off was we're talking about interfaces, and so what we're going to do is let's see. We're going to let me share my screen now. Right. Okay. And we'll get to this in just a second. But for now, I want to go back. Okay. Where we finished off was we were talking about this whole interfaces, and one of the interfaces that we talked about was the comparable interface, right? So if the purpose, one of the purposes that we can do, we can use the comparable interface for is we can use it so that we can compare two objects together. We can define what it means for two objects to be equal or for one to be greater than the other. Not everything has to be done that way, but it is nice if we want to be able to sort a list of items, right? So, for example, if we had a list of students, an array list or an array or, just any type of list, an ordered list of something. So let's use for an example, a student. Sometimes it's really useful for me to be able to sort you guys if I have you in a list. So, for example, when I'm grading your quizzes or something like that, it's really useful for when I'm putting those grades in or for me to sort it. Now, the way I would want to sort it would be alphabetically. That's that to me is the fastest way to sort you guys, right? So that I take your quizzes or your exams or whatever, and I put them into an alphabetical order. So that whenever I take the grades and I put them into my spreadsheet, I have that in alphabetical order, and it's easy that way because it's my brain thinks in that way, like it can sort you that way. When I pull up an OBS system and I say, give me the list of all the students who are in the class, and especially like if we were meeting physically, and if we were doing this midterm exam I just talked about, if we were doing that in a physical classroom setting, then the list would not come out in an alphabetical order. It would come out in ordered by your student number, right? And so does that mean that somebody who has a higher student number is better than another student with a lower student number? Of course not. You wouldn't say that, but it is a way that the system can compare two uh, of the same type of thing and be able to order them quickly. If we didn't have some way to compare two students to each other by student number or by first name or by last name, if we didn't have a way that we could compare you to, we couldn't sort you, right? We couldn't determine which one would be considered, quote unquote, greater than the other, right? So this is why being able to compare two objects is helpful to us so that we can sort them, right? Um, the nice thing about implementing the comparable interface, one of the nice things is that we get to determine what it means for one thing to be greater than, equal to, or less than another thing. Okay, let me back up one slide. I realized when I pulled this up. Let me back up one slide, all right, and be able to tell you some of these things that involving the instance of operator. So we talked about this a while back. The whole instance of operator tells me if it's a type of thing, right? So, but it works not only for parent and children classes. So n is an integer. N is an instance of integer. That would be true. The reason why is it is an integer object. Now, n is also an instance of object, and the reason why is because object is the parent of integer. Okay, so if something is an instance of a class, it is also an instance of all of that class's parent classes. Okay? But we can also use the instance of operator to determine what interfaces that thing is implementing as well. So comparable is not a class, comparable is an interface. And so N is also an instance of the comparable interface, okay? So in order to use the sort method, which is a fast way to sort an array, right? The only way that we can use that method, the elements in the array must be instances of a comparable type, okay? That does mean that all, what's the word? All primitive types, so not integer, but int, not the double with a capital D, but double with a lowercase d. Those are also all comparables as well. Those are also going to be comparable things as well. But those are more easy to understand. All right. Okay, so let's talk about our rectangle example. Now, remember, rectangle was a type of geometric object. Now, geometric object we decided would be an abstract class. We're going to have this abstract idea of a geometric object. There's going to be certain things that all geometric objects will have in common. They'll all have an area. They'll all have, they also put stuff like color in there and date created and stuff like that. Oh, they'll all have a get area method. They'll all have a get perimeter method, right? But we didn't make this a concrete object. We didn't make this a concrete class. We made it abstract, and the reason why was because we didn't want there to be any creation of an object that was just a geometric object, like this amorphous, we don't know what it is, geometric object. Instead, what we're going to do is we're going to say, okay, we're going to have a rectangle class. We're going to have other classes like circle. Maybe we could create a triangle and things like that. Right? And it's going to extend the geometric object class. So it will be a type of geometric object. Okay. Now, rectangle on its own, we understand how to, what a rectangle is. It has a length and a height, or a width and a height. And what we need to implement from the geometric object class would be things like the get area method. So the rectangle will have to create the code for what the get area method, and you guys know how to determine the area and the perimeter for a rectangle. Right? So we have to implement those methods, and we do that. Now, then we're going to get down to we want to be able to take two rectangles, or maybe a list of rectangles, and sort them. We want to be able to compare two different rectangles together, but on its own, the rectangle class does not allow us to do that. We don't have a definition in the rectangle class. If we go back and look over, if we were to go back and look at our Java, right, and look at the rectangle class, we would not see a way to compare two rectangles together. Right? So what we need to do is we need to have a way to compare two rectangles together. They must implement, sorry, let me go back. Let me undo what I just said. Because what I'm saying is in order to sort a list, an array of rectangles, they need to implement the comparable class. The comparable interface. And they must have the compare to method defined. Okay. Now, the comparable rectangle can implement the comparable interface. It can define the compare to method. Could we have just had the class implement the comparable interface and put it in there? Of course we could. That would be fine. There would be nothing wrong with that. The reason why this set of slides and why these examples do it this way is because it's introducing new concepts on top of existing concepts. So instead of just throwing the comparable stuff into the rectangle class, we decided to say, okay, let's define this thing that's a rectangle. Now let's add to that rectangle. Okay. We'll look at this example in just a moment. I want to finish off the slides first, and then we'll move into examples. Okay, and then finish off with a new thing I want you to learn, a new tool that I want you to have access to. Okay. All right. Now, let's talk about another interface that's important. The clonable interface, all right, is a way that we can make a copy of an existing object, a clone of an existing object. Now, remember that if we were to take two objects, if we were to say, take a rectangle R1 and say rectangle R1 equals rectangle R2, right? Now, if we just use the equals operator, let me pull this up and show you what I'm talking about. Okay. Let me just put down here. Like if I were to just say rectangle, let's say we had a rectangle R2, R1 already defined. If I were to run this line of code, rectangle R2 equals rectangle R1, right? Equals R1. Would that make a copy of R1 and put it into R2? And the answer is no. It wouldn't make another rectangle. All it would do would have R2 and R1 point to the same thing, the same exact object in memory. That's not usually what we want to do. Usually what we want to do is we want to make a copy of this thing that exists and then be able to make some minor changes to it. All right. So for example, I might want to make a copy of a student, for example. I might want to take one student. Let me take a look at who's on the call. Okay, so we've got, let's see. Let's say I wanted to, just down here at the bottom, Eunice and Yusuf over here, right? So what I might want to do is I might want to take Eunice's information, right? Make a copy of him, make a copy of that student, and create this new student over here, and then make some minor changes, like maybe change the name of this new student, maybe change the student number. But there's some information that already exists for Eunice that I just want to make a copy of that over here for Yusuf. Okay, especially if maybe if you were in a class that involved a group project, all right, and you wanted all their grades to be the same for all the aspects of the group project, right? I might make a copy of that student and bring that student over and then just make some minor changes. Right? But if I do this, if I do rectangle R2 equals R1, and I'm not making a copy, if I make any changes to R2, those same changes happen to R1, and that's not what we're wanting to do, right? You know, so maybe it'd be easy if I just went ahead and showed you what I'm talking about. 10 by 20, right? Should work. Okay, so we have this R1, right? That's a 10 by 20 rectangle. So now if I say, okay, I want to make a copy of that. Okay. I have noticed that they point to the same thing, right? They're the exact same object. So now if I say, okay, now I want R2, I want to change its width. Change its width to 15. Notice that it changes it for both of them, right? Right? That's not what we were wanting to do. We were wanting to make a copy of R1, and we were wanting to just change one aspect of that rectangle for the new rectangle. And what we did instead was we changed the original rectangle. That's not what we're trying to do. That's not right. And so, and for a rectangle, you might say, well, man, Hoja, why don't you just do rectangle R2 equals a new rectangle? Why do you need to go make copies of things? That seems like a lot of work just to, just do nothing, right? And yeah, for a rectangle, that seems like you could just do it that way and that'd be easier. But what if there's a lot of information, a lot of data, a lot of attributes we want to copy over, and we just want to change one of them? We just want to change one thing, right? Then making a copy would be a lot easier, right? So, for example, if you had, for example, a document, an assignment, like I was making you guys an assignment, there's a lot of information that's the same, right? The header is the same, the semester is the same, the title of the course is the same, the format is the same, right? These are all things that I would do the same, right? So let me just go ahead and pull that up as an example. Right there. So if we go into the assignments folder, so if you look at assignment 1 and you look at assignment 2, right? None of this should be new to you guys, right? Notice there's a lot of similar formatting. What I did was I made a copy. I made a copy of this document and then just made some changes. Made some changes to that document, right? We could say that this document, assignment 2, was a clone of the assignment 1 document, right? We wouldn't want me to make changes to this document, to the assignment 2 document, and have those same changes happen to assignment 1, right? That's not what we would want, right? Okay. So the reason why I'm getting into all this is because what if there were an easy way to make a clone of one object and put it into the other? Okay. Calendar is an example, but another example that we will take a brief look at if we have time is the house example. Okay? Where you have a house, it has certain attributes. We want to copy one house into a new house, okay? And then we want to be able to just make some few minor changes to the second house and not have those same changes happen to the first one. All right. So one aspect that we need to talk about in terms of cloning is the differences between a shallow and a deep copy. Now, a shallow copy, all it does is it makes a copy of the different values, all right, the different primitive data types, okay? So ID, area, these are all primitive data types for the house. So it makes a copy of those, but it also copies the reference value, the primitive. So it copies all primitive data types. So remember that this when built is a date, so it's an object type. All right. So what happens is, just like string, this reference gets copied instead of the value inside of that. So it's like basically just a first level, it copies this value into here, this value into here, this reference value into here. Remember, this reference is an address, it's a primitive data type, it's an address to an object somewhere in memory. So it just copies that. So now they both point to the same date. If there was a string value, a house 1 name, for example, that string value gets copied, the actual string gets copied. That way, we're not any objects inside of this, those objects, the value of those objects don't get copied. The actual object itself, it points to the same object down below. Okay. Deep copy basically is, think of it as recursive. Okay. That when this clone happens, all right, in primitive data types, values get copied, right? But then object data types, they all make a copy of that object and copy it into a new object and make that reference the new object. Okay, so it's kind of, oh, I'm gonna make a clone of this object. Okay, well, what I'm gonna do is any objects inside of this, like a date, I'm gonna recursively create a clone of that and make it the new one. And it does this for all objects inside. So that's the difference between shallow and deep. Shallow is just first level. I'm just making a clone of primitive stuff in my first level. Deep is I'm recursively going through and making copies of all the objects that are inside of there as well. Okay. All right. So the question that some of you might be having is, well, how do I know whether or not to use an interface or an abstract class for something? Right. So if we're using an interface, right, remember that the data must all be constants. We're not allowed any non-constant attributes. And all of the methods in an interface must be abstract. We cannot have a method that is defined in an interface. Right? An abstract class, though, on the other hand, can have any type of data. Can have can have abstract. Sorry, it can have constants, but it can also have variable data as well. An abstract class can also have concrete methods. You can have defined methods. Okay, so remember the main thing that we want to remember when to use which and when to use interfaces, when to use abstract classes, is if we are defining something about the way a thing behaves, but not necessarily anything about it, all right, then that's an interface. If we are defining something that more of a what it is, what type of thing it is, all right, then that's more that we're totally thinking of a parent class and possibly even an abstract class. Okay, I'm trying to think of one other thing, because as we'll get into it, let me pull up this slide because this is important for the class can have only one, right? So if we're dealing with abstract classes, then what we're saying is we're saying that any children of this abstract class is going to be a type of this thing and only a type of this thing. It cannot have parents can have multiple children, but children can only have one parent in object-oriented program. Okay, in terms of abstract classes versus interfaces. The other aspect is a class can implement multiple interfaces, and interfaces themselves can implement other interfaces as well. Okay, so if you want to define some multiple things that a class is going to pull from, abstraction information from, then you're probably thinking more of an interface type things. Okay, and remember that anything that a class implements or extends, it's also considered an instance of, right? So this whole instance of class 2. So class C is an instance of objects, is an instance of class 1. It's an instance of interface 1. It's an instance of all of these things. Everything on the page, class 2 is an instance of. Let's see. Okay, one thing to be aware of is when we're dealing with multiple interfaces. So the nice thing about interfaces is we can implement more than one. That's a nice thing. The concern there is what happens if two interfaces that I'm implementing both have the same a similar signature on a method. All right, so we have two both with both with parameter types as far as the parameters that we're passing, but different return type. One returns a string and one returns an integer, right? This could be a big problem because then when we implement that method, the compiler doesn't know which of the two methods we're implementing, right? So what will happen is the compiler will say, I'm not sure which one of this you're trying to do, and so it will so it'll give us a compiler error. Okay, so if that happens, yeah, it's rare, but it is a concern that we need to be aware of. Okay, all right. So basically, this slide kind of summarizes what I said earlier, where if what you're talking about is a kind of relationship, this is a thing, this person, this student is a person, a grad student is a student, right? If there's a strong is a relationship, right? Then we're talking about a parent-child relationship, and you should use a class, possibly an abstract class. Okay, a weak is a relationship more of a it does this, it has these qualities. It is comparable. It is what the example we talked about yesterday is edible, right? Those kinds of things. That's more of an interface type relationship. Okay. All right, the rational class, we'll talk about that one because it implements the comparable interface, but not because it's not on its own. It extends the number class, and so therefore it implements the comparable interface, I believe, because the number class implements the comparable interface. We'll talk about, I want you to go ahead and look through designing a class because this is important. We're quickly running out of time for today. Okay, but I do want you to understand how when we design a single class, why a single class might be important, right? And how we do that. So for example, you might use a class for students in a university. Right, but you shouldn't make students and staff the same class. Like, I wouldn't want to have students be the same class as staff. Now, they could have the same parent. We could make them both extend from the person class, right? Or we could even have another class that's more refined, like a university person class or something like that, right? But because students and staff, students and professors, teachers, whatever you want to call this, right? You would put them as different classes because they represent different things, because they represent different, and all students have certain things in common, and all staff have certain things in common, and so that's why you would want to represent them as two separate things. But then, like I said, you can make them both extend from this other thing called a person class that has all those things in common, that because all people have certain things. Okay. Go ahead and look through more of these designing the class. The reason why I wanted to get into this is because what I'm going to do is for your next assignment, but your next semester assignment, I'm going to ask you to create a UML document, and I want to introduce you to a tool. I want to introduce you to a tool that you can use to do that. Okay, let's see. Pull this up. Okay, now there is no requirement to use this tool. I want you to hear me say you have to use this tool. I just want to introduce it to you because I think it's a useful tool. Okay, now you can get to it through one of two ways. You can either go to draw.io, that's the old website that they used to. Now they're calling themselves diagram.net. Okay, so this way to get. What I like about this tool is that it can connect directly to your Google Drive. Okay, UML. I want to, and it can connect directly to my Google Drive. So I'm gonna pick a folder. I'm gonna go into the classroom. CSE 102. And I'll just put it into the assignments. Assignments folder. I guess I could have put it in the lecture examples. So I'll move it to the lecture examples folder when we're down here. Okay, so now what's it going to do? It's going to create this example UML class diagram. You should be able to analyze and understand this. If I were to say, I want you to take this diagram and I want you should be able to, okay, where these sections are all attribute. This section is a method. We would call this, the general term for this is operation. It's something this class can do. All right, and we can, but in Java code, this would be implemented as a method. Okay, so what I'm going to do is I'm going to take this and I'm going to delete this. All right, so because I want to show you. Okay. Right. So we can take a class and bring it in, right? And we can give it a name. So let's just talk about the classes, right? So we will go up here, right? The rectangle stuff here, right? And what was we have a class. So I don't think they have an abstract class option. Yeah, I didn't think so. Okay. So we have a class. We'll call it geometric object. And let's see. Edit. Text. That's what it's text. Okay. Say make it italics. And what does italics do? Italics says this is an abstract class. And I can fill in my fields, my attributes, and my methods. Right? And then I can take another class and I can bring it over here. And I can say this is, we're going to call this a rectangle. Right? And we want to say that rectangle extends geometric object. And we have that right there. All right? And you can put it here, and then you can put it. All right. And the nice thing is, like, I can move this around, and notice that the arrow follows. So I can move this around, and it'll follow it, and it'll make things nice and clean, right? Now, and then the cool thing is you can take this, and you can copy and paste, right? Or you can duplicate, right? So now I can have another. So if I were to say, okay, I want to do a circle, right? I can do that here. And then I can duplicate this, right? And now I have two things that extend the geometric object, all right? Oh, that's not. Oh, that's fine. Now this is especially useful for if two classes have similar names. So remember we did the comparable rectangle, right? So now here we have, right, our abstract class, and our rectangle extends that, and our comparable rectangle extends this. And then let me pull up my interface. So I have an interface, right? You can use that. You could also use this if there's a field and methods that we need to define too, right? Remember, our interface was what? Our interface was called the comparable. Right. And instead of extends, now we want to implement, right? Right. And just like before, I connected these together, and so I can move this around and the arrow follows, okay? Again, I am not saying you have to use this tool to create any UML diagrams that we might ask you to do, but what I am saying, it's very useful, especially if you realize in the middle of making it, like if you were to draw a diagram, or if you were to draw a diagram in a by hand, like on a piece of paper or on Microsoft Paint or something like that, and then you realize, oh, I need to change this because this should have had this other class in here. Then you got to like erase stuff or redraw stuff, and then it just gets kind of frustrating, right? But this way, if I realize that I needed to add a class somewhere in here, I could just do that. I can just take a class and just bring it in here and do it, right? Okay. And then the nice thing, like I said, this tool connects to your Google Drive, and you can export as a picture, as a number of different picture styles, as a PDF, right? And you can save it, and you can come back and you can make edits to it later. Okay. So all this was again it's going to be part of assignment 3 that's coming up soon. As soon as assignment 2 is finished, be looking for assignment 3 to come out, and then you'll need to draw a UML diagram as part of that. Okay, as part of that assignment. Okay, so I want to make sure you understand how to take a system here, right? How to take a defined system and be able to draw the different UML components to make that system happen. Okay. I have run out of time for today. I've run out of time to go over these examples, right? This comparable rectangle stuff. So what I may do is I may record a separate lecture because we really need to move beyond this topic this week. So what I'll do is maybe record a separate video that will include going over these examples, and I will post that when that's done. Okay, so let me move back to here, and show the conversation. Okay, does anyone have any questions regarding this today's topic? You can either unmute your microphone and ask through the meeting, or you can write a comment. I'll give you a few seconds. All right, so like I said, be on the lookout for a few things that are coming up. You have assignment 2 is due, I believe that's Monday, if I remember correctly. And also, as soon as assignment 2's due date has passed, I will post the assignment 3. Assignment 3 is not going to be yeah, okay, thank you, Eunice. Yep. As much code heavy. It'll be more, like I said, UML diagram, and it's going to be more to help understand how well you understand testing as well, writing test cases. So that'll be assignment 3. And then, like I said, today or possibly tomorrow, I'm hoping for today, but today be on the lookout for, on the OYS system, there will be a posting about the midterm exam. Okay, the midterm exam assignment that we're going to be giving you guys. Okay, thank you guys for attending. I will see you next week. And remember, yes, you will have a lab. The plan is for you to have a lab this week with Taha and Alperen. So be ready for that tomorrow. And other than that, I'll see you next week. And oh, let me make sure you hear me say this. For the assignment, it's due Monday, so make sure if you have any questions concerning assignment 2 that you get them to me sooner rather than later. If you message me Monday afternoon with questions about assignment 2, you might not get an answer before the deadline has passed. Okay, so make sure you get to work on that sooner rather than later and get questions to me sooner rather than later. Okay. All right, guys. Thanks for attending. I'll go ahead and stop the recording now.